Harpoons. An object entered our solar system in 2024, looking as ordinary as any distant comet.
African-American astronomers first logged 3I Atlas with little excitement, but subtle anomalies in its trajectory caught their attention. At first, its motion seemed like simple celestial drift. Then patterns emerged that defied natural expectations. Simulations showed the object refusing to wander randomly. Instead, its path sharpened, as if following a plan.
Comets usually wobble from uneven heating, but Atlas moved with a strange, steady confidence.
The real surprise was its destination. Its trajectory aimed straight for Jupiter's gravitational domain.
Scientists call that region Jupiter's Hill Radius, its gravitational territory. Inside it, Jupiter's pull overpowers the Sun.
Think of the Hill Radius as a cosmic harbor for long-term stability, a place where objects can linger effortlessly.
And Atlas is aligning with it more accurately than most spacecraft. Its precision is astonishing.
The target lies over 50 million kilometers from Jupiter, yet Atlas approaches with uncanny accuracy.
The margin of error is incredibly small. Even expert navigators rarely achieve this alignment.
Imagine throwing a dart from New York and hitting a coin in Los Angeles. That's the level of precision here. Natural objects pushed by heat and dust don't behave this cleanly. Chaos is the norm. Yet Atlas glides as if untouched by turbulence, serene and unwavering.
Comets near the Sun usually erupt with chaotic jets, but Atlas stayed calm. Its coma looks unusually uniform for a comet. That symmetry is hard to explain.
Such symmetry could be natural or engineered. The data doesn't choose sides yet. More curious is the orbit tightening after perihelion. Heat should destabilize it, not refine it. Comets usually wobble violently after such heating, but Atlas stabilized even more.
Something beyond simple ice sublimation seems involved. The object behaves too cleanly.
Some argue solar heat alone explains it. Others see signs of deliberate adjustment.
The strangest timing was during solar conjunction. Atlas shifted when Earth couldn't watch. During that blackout, instruments were nearly blind. Yet the path subtly corrected.
Maybe coincidence, maybe cover. Science must consider both.
When Atlas passed near Earth, it showed no curiosity. No turn, no scan, nothing detectable. It ignored us like a car ignoring a roadside sign, as if we weren't part of its mission.
That indifference is unsettling. It suggests Earth isn't the destination.
Jupiter, with its immense magnetic field, is another matter. It's a natural power source. That magnetosphere could fuel devices indefinitely, natural or artificial alike. And Jupiter's Hill Radius is ideal for long-term observation. Quiet and stable. Such an object could release small probes into stable orbits, a distributed network. This aligns with Sentinel theory, the idea of silent watchers seeded across star systems. But science must start with natural explanations. Imagination follows evidence. Still, the precision is difficult to ignore. The numbers point to intention.
Experts compare it to spacecraft navigation. It's that exact. This forces the question: nature or engineering? The object's motion lacks random jitters.
That steadiness is puzzling.
Even fragments of natural comets tumble wildly. Atlas stays ballast.
Researchers keep rechecking the numbers. Precision demands skepticism.
Yet every update points to Jupiter's gravitational gate. The target holds.
Once it enters, we'll know more. Fragmentation or stability will reveal intent.
Natural breakup appears chaotic. Artificial deployment appears organized.
The spacing of fragments will matter. Patterns can betray purpose.
If Atlas slows slightly, that will be a clue. Natural objects rarely slow cleanly.
But acceleration would also be meaningful. Every change paints a picture.
For now, the mystery sits between two explanations, neither proven.
Some argue we see patterns where none exist. It's human nature.
Others insist the precision is undeniable. Ordinary comets don't behave this way.
Jupiter attracts many wanderers, but few arrive on such razor-sharp paths.
Even fewer approach with such calm steadiness. It feels almost intentional.
Imagine standing on Callisto, watching Atlas approach. A faint, persistent star would rise in the sky.
From there, its path would appear too straight to be chance, like a ruler drawn across the heavens.
Whether artificial or natural, the behavior remains intriguing. Questions outweigh answers.
Nature can surprise us. It often rewrites expectations.
Mysteries are valuable. They push us to explore deeper.
As Atlas nears Jupiter, observatories worldwide follow its movement.
New measurements refine the puzzle. Some clarify, some complicate.
Science thrives in the unknown. It embraces uncertainty.
If Atlas is natural, we gain insight into interstellar comets. If it is not, the implications are much larger.
For now, Atlas travels silently, a visitor with no introduction.
Whatever awaits near Jupiter, we watch carefully, patient and curious.
Think of its movement like a story written in gravity. Every curve matters.
And Atlas is approaching its final chapter near the Hill Radius.
When it crosses, the mystery deepens. That moment may be revealing.
If it fragments, we'll study the pieces. If not, we'll ask why.
The universe doesn't promise answers, but we keep listening anyway. Curiosity drives us forward, not fear. That's the spirit of exploration. Atlas reminds us how much we still don't know, and how much there is to learn. Ignorance is not failure. It's the beginning of discovery.
In coming months, Atlas will reveal more through subtle signals.
Whether those signals whisper or shout, we will hear them.
Patterns always leave traces. Atlas might be such a trace.
Its precision is either a natural miracle or a deliberate signature.
Either possibility fuels our wonder. That is the heart of astronomy.
As Atlas approaches Jupiter, the universe feels less distant. And maybe soon, we'll know why this traveler chose such an extraordinary path. Until then,
The traveler continues deeper into Jupiter's domain, and we wait for the next clue. During solar conjunction, Atlas vanished behind the sun, hidden from every telescope on Earth. When it reappeared, its speed had changed in a very specific direction. That timing raised eyebrows because we couldn't observe the moment it shifted. Natural comets rarely adjust velocity so cleanly during such heat.
imagine a car speeding inside a tunnel and exiting slightly faster.
That's what Atlas looked like as it left the sun's blind zone.
The question is whether that shift was chance or intention.
Comet jets often cause unpredictable pushes, but no jets were detected here.
Atlas changed course without leaving the usual signs of heating.
That's why scientists keep rechecking the numbers again and again.
The sun's glare made our instruments nearly blind during the shift.
Atlas seemed to use the moment of invisibility to refine its path.
But why would any object aim for Jupiter with such accuracy?
Jupiter holds the largest magnetic field in the entire solar system.
That magnetic field can power many kinds of devices indefinitely. Think of Jupiter's magnetosphere as a giant cosmic generator.
For machines, that region is a paradise of free energy.
Around Jupiter lie several Lagrange points, perfect for stable parking. These points allow objects to stay put without much fuel. Imagine sitting in a space chair that never tips over.
That's what a Lagrange point feels like for a spacecraft.
Jupiter's Lagrange points are ideal for long-term surveillance. They offer steady views of the entire inner solar system. An observer there could watch everything we do without interruption. So it's no surprise that Atlas appears to be heading there. But another mystery unsettles astronomers even more. When Atlas passed near Earth, it showed absolutely no reaction. It didn't shift orientation or emit any detectable heat. It treated Earth as if we weren't even here. If it were observing us, we would expect at least one small adjustment. But there was no curiosity, no hesitation, nothing at all. That indifference suggests Earth is not the target.
Imagine standing on a balcony while a stranger walks past without noticing you.
That's how Earth seemed to Atlas, just scenery along the route.
So why would something ignore the only life-filled world it sees?
Maybe its mission has nothing to do with biology at all.
Maybe it cares only about physics, energy, and stability. Jupiter offers all three in overwhelming abundance. We humans think of ourselves as important, but space disagrees. Atlas behaved like a traveler, passing a small town without stopping. After all, not every journey requires meeting the locals. Some paths are meant for destinations far greater than Earth.
The alignment of Atlas's path with Jupiter seems too precise to dismiss. But precision alone doesn't prove intention. Nature can surprise us.
Still, the combination of timing and accuracy is worth examining.
If Atlas wanted to avoid attention, conjunction was the perfect moment.
No telescope could track it clearly inside that blinding zone.
Then it emerged more aligned than before, as if corrected.
Why refine a path during the only moment no one can see you?
That question keeps many astronomers awake at night.
Jupiter's magnetic environment could run autonomous probes forever. Energy-collecting devices would thrive in such conditions.
And Lagrange points offer positions that barely drift over centuries.
Any long-term observation network would love such stability.
Does that mean Atlas is delivering something? We cannot know yet. But its disinterest in Earth speaks volumes.
It didn't scan our atmosphere or track our signals.
If it were curious about humanity, it hid it flawlessly.
Instead, it treated Earth like background noise. To Atlas, Earth may be just another rock in a crowded solar system. Jupiter, though, is impossible to ignore.
Its sheer size shapes the architecture of the entire solar system.
No wonder something might aim for its gravitational sanctuary.
If Atlas continues undisturbed, the encounter will be revealing.
Will it fragment naturally? Or deploy something with purpose?
Observatories worldwide prepare for that moment.
Every shift in motion will matter as Atlas draws near.
We are watching a silent traveler on a path that feels deliberate.
Whether natural or engineered, its journey challenges our assumptions.
The universe rarely sends mysteries this precise.
And yet Atlas keeps moving, indifferent and exact.
Perhaps the truth lies beyond what we expect from comets.
Or perhaps we're witnessing a natural wonder we don't yet understand.
Whatever Atlas is, its silence speaks louder than signals.
And as it approaches Jupiter's domain, we await the next clue. Every interstellar visitor tells a different story, and Atlas seems determined to tell an unusual one.
Some cosmic travelers are ordinary, but Atlas, an elderly black woman, behaves just a bit too precisely. Imagine standing on an icy moon of Jupiter, watching a bright object drift closer.
But what if that breakup was not random at all? Objects entering Jupiter's gravity zone often crack under tidal forces.
Yet the direction those fragments travel can tell us everything.
Natural debris scatters chaotically like shattered glass.
But engineered fragments would move with purpose.
How many probes has Atlas deployed so far?
We're showing 10,000, synchronized perfectly with the Atlas trajectory.
These probes might settle into Jupiter's stable gravitational pockets. From those pockets, devices could observe for centuries.
To us, the entire event could look perfectly natural.
That subtlety is what makes Atlas so hard to categorize.
We've seen strange behavior before with interstellar visitors. In 2017, Oumuamua left scientists puzzled with its odd acceleration.
It lacked a comet tail, yet moved as though pushed by something.
2 years later, Borisov reminded us what a normal interstellar comet should look like.
Borisov had jets, heat signatures, and unmistakable ice vapor.
Atlas sits somewhere in between, neither typical nor impossible. That gray area is exactly where scientific curiosity thrives.
Unlike most comets, Atlas shows a surprisingly even coma. Its glowing cloud appears smooth and symmetrical.
Most comets have uneven heating that creates lopsided plumes.
Those plumes make comets wobble unpredictably.
But Atlas remains strangely stable for something supposedly active.
Its coma looks almost too uniform to fit the usual patterns.
Some astronomers argue this could mean Atlas is simply slow spinning. Others think its shape could naturally produce even heating. Yet others see the symmetry as a sign of something intentional.
The lack of jets makes its smooth flight even more peculiar.
Comets rarely behave this quietly when approaching Jupiter. Atlas, however, glides like a machine built for silence.
If fragmentation occurs near Jupiter, it might mask a deployment event.
The giant planet's gravity could help hide any purposeful release.
Imagine probes drifting into long-term positions without burning fuel.
Jupiter offers everything a sustained observation network might need.
A network placed there could watch the entire solar system.
Meanwhile, Atlas shows no interest in Earth whatsoever.
During its flyby, it didn't adjust course or emit heat.
It behaved exactly as if we were irrelevant to its mission. If a probe wanted to study us, it would likely shift orientation. But Atlas didn't even flicker as it passed by our planet.
That calm disinterest is one of the strangest clues we have.
We humans expect visitors to stop and look at us.
Yet Atlas acted like a traveler, ignoring a roadside town.
Its attention, if any, seems focused entirely on Jupiter.
The closer it gets, the more significant each motion becomes.
Observatories worldwide watch it with growing anticipation.
Will Atlas behave like a comet or reveal something else?
A team of African-American scientists hopes to catch every fragment if the breakup occurs.
Fragment patterns might reveal whether we're seeing physics or engineering.
Natural debris spreads irregularly, but coordinated motion is a red flag.
Jupiter's immense gravity will magnify any intentional behavior.
Even tiny guided fragments would stand out under such forces. Some models predict fragment lines could settle into Lagrange points.
These points are the perfect hideouts for long-term devices.
Atlas could seed multiple positions with minimal effort.
Of course, this is just one hypothesis among many.
Nature often mimics intention better than we expect. But nature rarely holds symmetry as tightly as Atlas does. Its quiet, even glow remains one of its great mysteries. If Atlas deploys fragments soon, the patterns will matter. A coordinated release would rewrite how we see interstellar visitors.
A natural breakup would simply add Atlas to comet history.
Our instruments prepare for either possibility.
But everyone agrees the next few months could be revealing.
If Atlas mirrors Oumuamua, we may face more unanswered questions. If it mirrors Borisov, things may finally make sense.
Atlas refuses to fit neatly into either category. It glows with both familiar and unfamiliar traits.
That's what makes this moment so compelling for astronomers.
New cosmic visitors force us to rethink so many assumptions.
Atlas might soon show us whether we've underestimated interstellar physics.
Or it may reveal nothing at all, leaving us puzzled.
Either way, its journey pushes us to look deeper into the unknown.
The next step is simply watching, waiting, and learning.
Whatever happens at Jupiter may define its entire story.
And when the moment comes, we may finally understand what Atlas truly is. Science always asks whether strange behavior can still come from natural forces.
Atlas could still hide natural explanations beneath its unusual path.
Imagine a comet with hidden pockets of ice deep inside its core.
When the sun heats those pockets, gas can escape in surprising ways. These tiny vents might push Atlas steadily without looking chaotic.
Even asymmetric gas release can create stable thrust over time.
So natural physics might still mimic intentional behavior.
Nature often surprises us with patterns that feel engineered.
Atlas may simply be built from rare materials we haven't seen before. Its internal structure could behave unlike typical solar system comets.
But if Atlas is engineered, the next phase will be even more telling.
Once inside Jupiter's influence, every movement will matter.
Imagine multiple small probes emerging during a seemingly normal breakup. To the naked eye, it would look like a comet shattering harmlessly.
But each fragment might quietly settle into a stable orbit.
It could form the backbone of a long-term monitoring network.
Such a network might do nothing more than watch silently.
But another design could collect data and beam it elsewhere.
Weak signals might travel across space without drawing attention. A more advanced system could even analyze our technology from afar.
A rare possibility is a network capable of direct intervention.
But such a system would likely leave detectable energy signatures.
So observers on Earth look for any coordinated motion among fragments.
Natural debris never moves with perfect harmony. Only intentional control keeps fragments aligned over long periods.
If Atlas deploys a network, its behavior will reveal the purpose.
A pure surveillance system would remain quiet for centuries.
A data relay would eventually point outward to send information.
An intervention system would react to activity in our inner planets.
Black female scientists prepare to distinguish these possibilities through motion alone.
For now, every eye turns to Jupiter as Atlas approaches.
But one moment remains especially suspicious in Atlas's journey.
Perihelion gave Atlas its greatest burst of solar energy.
This is when natural or artificial systems would behave most actively.
Just as important, solar conjunction hid Atlas completely from Earth.
No telescope could track its precise motion during that window.
If Atlas shifted direction intentionally, this was the perfect moment.
A covert burn would blend seamlessly into natural heating effects.
Even a small thrust can reshape a long-range trajectory.
After conjunction, Atlas emerged on a cleaner, more refined course. But physics alone doesn't rule out natural forces either. Many comets behave strangely when warmed unevenly. Some have deep chambers that release gas in stable streams.
Rare compositions can mimic propulsion without true engines.
So we must weigh intention against coincidence carefully. Atlas keeps us suspended between both possibilities. If a network is deployed, its purpose determines its behavior.
A watch and record system would operate silently and efficiently.
A data transmitter might create brief directional signals.
A reactive system might adjust orbit in response to activity.
Each scenario creates patterns scientists now search for. Our job is not to assume intent, but to read the sky honestly.
Atlas may simply be a comet built from unusual ingredients.
Or it may be a device using gravity and timing with remarkable precision.
Both explanations remain on the table for now. What matters is how Atlas behaves as it nears Jupiter.
Fragmentation patterns could confirm natural processes.
But coordinated fragment orbits would suggest something more.
We stand at a rare crossroads between possibility and evidence.
Atlas won't give us answers through speculation alone.
Only its movement will reveal what we're actually witnessing. For now, the safest view is that nature may still explain everything.
But we must keep open minds as new data arrives.
If Atlas performs another discrete maneuver, we will notice.
Jupiter's gravity will amplify every subtle choice it makes. Any intentional behavior will stand out under such forces.
Even natural features might become clearer near the giant planet.
Atlas is heading into a spotlight that hides nothing.
Soon, either its mystery will deepen or fade away. One thing is certain: the next actions won't be ambiguous.
The universe rarely gives us puzzles this finely balanced.
And Atlas sits right between natural wonder and possible design.
Whatever truth emerges, it will reshape how we view interstellar visitors. Atlas continues its silent journey toward Jupiter's waiting gravity. Soon enough, its true nature will reveal itself in motion. We entered an era where timing matters, just as 3I Atlas appeared in our skies. Atlas arrived right when our tools became sharper than ever before.
If it had come a decade earlier, we might never have noticed its odd behavior.
Now, AI allows us to detect things the human eye simply missed.
Imagine trying to understand a painting through fog, and suddenly the glass clears.
That's what AI has done for astronomy, clarifying the universe in unexpected ways.
Our systems now scan millions of images each night without fatigue.
They catch tiny shifts and flashes too subtle for human observers.
Because of that, Atlas enters a very different scientific world.
We aren't just looking harder, we're looking smarter.
And the anomalies we're finding are reshaping our expectations.
Take microflares, tiny bursts lasting only fractions of a second. These events were almost invisible before machine learning took over.
Microflares may come from turbulent magnetic activity on distant stars.
Or they might be something entirely new we never considered.
Then there's odd microlensing, brief brightening events caused by unseen objects.
Some of these lensing events last less than a heartbeat.
Yet their patterns suggest real objects, not noise.
And then we have the fast movers, objects with unusual speeds.
They aren't bound like normal asteroids, but not fast enough to escape. Some appear only for a frame or two, yet move with purpose.
Before AI, we would have dismissed these as detector glitches.
Now, patterns are emerging that demand closer study.
None of these anomalies are directly tied to Atlas.
Together, they signal something bigger happening in our understanding.
The universe hasn't changed. Our vision has. With sharper eyesight come deeper questions.
We now investigate signals from multiple angles at once.
No single tool can explain everything we see in modern astronomy.
To understand Atlas or any anomaly, we need interdisciplinary checks.
Spectroscopy reveals what objects are made of or how they reflect light.
Radio observations expose weak transmissions or unusual noise.
X-ray sensors capture high-energy events that optical telescopes miss.
And simulations let us test which scenarios actually make sense.
Think of it like solving a mystery with clues from many rooms. One telescope might see motion, another sees temperature. When they line up, the truth becomes harder to ignore.
For Atlas, this approach will determine whether its behavior is natural.
Or whether some signals come from processes we don't yet understand.
Timing also matters, the way Atlas accelerated during conjunction. It changed course when our view was almost completely blocked.
Perihelion gave Atlas energy. Conjunction gave it cover. If someone wanted to adjust course discreetly, that was the moment.
Sending AO Faisal. AI tools are the only reason we even spotted that shift.
They caught details invisible to human observers. Atlas arrived just when we began understanding the invisible.
And now we must interpret what we're finally able to notice.
The universe might always have been this busy. Or it might be that something is awakening our attention.
With AI, anomalies no longer hide in plain sight. We see patterns forming where once we saw randomness.
These tools reveal a universe more complex than expected.
And they raise new questions about visitors from interstellar space.
Each anomaly may be a clue we overlooked for decades.
Atlas connects to this larger story through its perfect timing.
It challenges us to rethink what counts as natural behavior.
And forces us to examine signals with fresh eyes.
Are we detecting nature's subtleties or signs of engineering?
Only interdisciplinary evidence will tell us the difference.
The next steps depend on careful coordination across fields.
Optical and radio observations must be matched precisely in time.
X-ray bursts need comparison with subtle thermal behavior. And simulations must attempt to recreate Atlas's strange moves.
Only then can we know if physics alone explains it.
Or if something intentional might be hiding in the noise.
What makes this era remarkable is how fast our insight grows.
And Atlas arrived precisely when we finally learned how to see.
The real question now is simple yet profound.
Are we discovering new physics or just noticing old patterns anew?
The answer will reshape how we understand interstellar visitors. And it will determine whether Atlas is ordinary or extraordinary. Sometimes discovery begins not with a signal, but with timing. And this timing may be the most important clue of all. Whatever Atlas truly is, AI has ensured we won't miss its story. And the universe may finally be revealing details we were never meant to overlook.
Astronomers know even tiny data errors can distort an entire orbital model.
A small mistake early on becomes enormous across planetary distances.
It's like driving with a GPS that's off by just 1 degree.
In space, that tiny angle becomes millions of miles.
That's why Atlas's unusual path must be approached carefully.
We must ask whether the anomaly is real or just a model artifact.
Early observations are especially vulnerable to uncertainty.
Dust, glare, or faint signals can all influence calculations.
Atlas challenges our tools, not just our theories. Even seasoned scientists must remain humble before imperfect data.
But if Atlas truly heads toward Jupiter, specific regions matter.
That's where the elegant idea of Lagrange points comes in.
Imagine spots in space where gravity creates perfect equilibrium.
These points act like invisible platforms holding small objects steady.
L1 sits between Jupiter and the Sun, with a sweeping view inward.
From L1, every inner planet aligns in a majestic arc.
It's an ideal vantage point for long-term observation.
L2 lies on Jupiter's far side, hidden in deep shadow.
L2 is perfect if you want to remain unseen for years.
Both points are incredibly attractive as cosmic hideouts.
A probe could remain there with almost no energy cost.
Nature creates these havens, but engineering could exploit them.
Some scenarios place Atlas as a potential visitor to these zones.
Yet we still question whether this trajectory is intentional.
Physics provides possibilities, not conclusions.
What we choose to see depends on how carefully we interpret the data.
But the deeper impact of Atlas may be psychological. We imagine aliens would study us because we are significant. But what if we are not central to anyone's plans?
Consider walking through a park, stepping past countless insects.
You notice them, but they don't shape your decisions.
What if, on a cosmic scale, we are those insects?
Atlas passing by without reacting may reflect that reality.
No turn, no signal, no curiosity, just silence.
But silence unsettles scientists more than hostility would.
It suggests we might not be the intended audience.
Or that we are simply irrelevant to its purpose. Some researchers struggle with that possibility.
Their careers revolve around searching for meaningful contact.
The idea of being overlooked feels surprisingly heavy.
It reshapes how we think about our place in the universe. Being unimportant may be harder to accept than being threatened.
Yet insignificance does not diminish human curiosity.
We explore not to be noticed, but to understand ourselves. Atlas reminds us that meaning comes from looking outward.
It forces us to ask deeper questions about existence.
Scientific uncertainty becomes part of that journey.
Data imperfections require humility, not fear. Whether Atlas is natural or engineered, our method remains the same.
We gather evidence from every angle possible.
Slow, steady analysis outperforms rushed conclusions.
Discipline keeps science grounded and honest.
The Lagrange points remain fascinating, independent of Atlas. They reveal how elegant orbital mechanics can be.
Those regions show nature's ability to create perfect balance.
It's no wonder these spots inspire speculation.
But speculation must always follow the data, not precede it.
Humans crave being part of a larger cosmic narrative.
We're wired to believe we matter,
on a universal scale.
Atlas challenges that instinct in a subtle but powerful way. It asks whether intelligence must always care about us.
The thought can be unsettling, yet strangely liberating.
Because meaning isn't given by the universe. We create it.
Atlas becomes part of that meaning simply by existing. Its mystery fuels the questions that drive science forward. Whether mundane or extraordinary, the search continues.
And each new observation sharpens our understanding.
One day, more data will clarify Atlas's true nature.
Until then, we balance caution with curiosity.
We must accept ambiguity as part of discovery. Every unanswered question keeps science alive. Atlas reminds us how much remains beyond our perception, and how rapidly our perception is evolving. Data error or cosmic intent, the universe stays patient. It holds truths we uncover, one observation at a time. Atlas may not care about us, but we care about the sky. And that curiosity ensures its story will never be ignored.
When an interstellar object nears Jupiter, science becomes more than physics.
Atlas forces us to confront questions far beyond its orbit.
Its presence sparks ethical debates about data and disclosure. What should the world know, and when should it hear it?
Imagine being the first to detect something unexplained.
You hesitate, unsure whether to announce or wait.
Transparency sounds simple, but reality is more delicate. Scientists must balance accuracy with responsibility.
Announce too early, and the world may misunderstand.
Announce too late, and trust becomes fragile.
That's why clear guidelines matter for discoveries like Atlas.
Who verifies unusual data before it reaches the public?
Who decides when an anomaly is significant enough to report?
And how do we ensure evidence is reviewed objectively? Cross-check datasets align on transparent overlays.
Atlas raises these questions, whether it is natural or not. In the coming months, several signs deserve attention.
First, we should monitor any unusual fragmentation patterns. Natural debris scatters randomly. Organized pieces do not.
A coordinated split could signal something intentional.
Second, a male African-American scientist will watch for coordinated slowdowns.
Comets decelerate naturally, but rarely with precision. Equal changes across multiple fragments would be unusual.
Third, spikes in emissions would draw attention. These bursts could hint at more than sublimating ice.
Emissions that repeat or pulse deserve deeper analysis.
Finally, we watch for any purposeful distribution near Jupiter.
Lagrange points would be the most telling destinations. If pieces settle into L1 or L2, questions intensify. These regions offer long-term stability with minimal energy. Probes could linger there unnoticed for decades. None of these signs confirm artificial intent on their own. But together, they build a case worth examining.
Good science demands a careful and balanced conclusion.
We must begin with natural explanations as our baseline. Nature often surprises us more than we expect.
Yet we must stay open to evidence that challenges assumptions.
If future signals exceed natural limits, we must acknowledge it. This is not sensationalism, it is scientific integrity. Evidence should guide belief, not the other way around.
That's why collaboration is essential during Atlas's approach.
No single nation or telescope can track everything alone.
Astronomers need shared data and open dialogue.
Coordinated observations reduce errors and increase clarity. Young radio teams, middle-aged optical teams, and older dynamic modelers must align.
In moments like this, global cooperation becomes essential.
Yet, communication with the public must remain thoughtful.
People deserve information, but not unnecessary alarm.
Transparency without context can create confusion.
Clear explanations build trust and understanding.
We should avoid exaggerating or hiding uncertainties.
Atlas's story is a test of scientific responsibility.
It challenges how we analyze, communicate, and collaborate.
It reminds us that discovery involves more than raw data.
Ethics shape every scientific decision we make.
Policy shapes how nations react to uncertainty.
What we chose to share now sets tomorrow's precedent.
Our choices will define how the world interprets anomalies.
In the coming months, patience will be vital.
Atlas may behave normally and settle the debate quietly.
Or it may reveal patterns we never anticipated.
Either outcome teaches us something valuable.
Science grows through questions we cannot yet answer.
And Atlas gives us many such questions at once.
We must resist jumping to dramatic conclusions.
But we must also resist dismissing real anomalies.
Observing carefully is our strongest tool. Listening to the data keeps us honest.
Sharing findings keeps us grounded.
And humility keeps us open to new possibilities.
Atlas may be ordinary or exceptional. Time will tell. Truth will emerge through careful global cooperation.
For now, we observe and learn as Atlas moves on.
Whatever happens, the universe remains our greatest teacher.
And each mystery deepens our sense of curiosity.
Atlas reminds us the unknown is not a threat, but an invitation. An invitation to explore truth without fear.
To share knowledge wisely with a watching world.
And to face the cosmos with clarity, patience, and unity.